Good morning to all. In this lecture, we are going to see about the cellular concepts. So, as we all know that day by day the usage of mobile phone has been increased by all in all domestic areas, but the frequency resources or the frequency spectrum available is unique, right? That is given by the IEEE standard. So, how to accommodate the day by day increased mobile subscriber within the limited frequency resources? So that leads to this concept which is called the cellular approach. So here we are going to see about the many techniques which is used to utilize the available limited resources in an effective manner to accommodate the day-by-day mobile subscribers. So the cellular approach, it is a concept which is used to explain the accommodation of the number of subscribers at an affordable cost in the limited frequency research. So the first and foremost thing in cellular approach is the entire geographical area has been divided into number of small areas, and each and every small area has been called a cell. And each cell can able to cover a particular radio coverage with a limited number of mobile subscribers, and each and every cell can have a separate base station with a number of RF channels. So here the concept is the repeated use of the same frequency by the multiple number of users. That is the meaning for dividing the entire area into number of cells. So the frequency used in the given cell area will be simultaneously reused at a different cell which is geographically separated. So for example, if you have the group of 7 cells, right? If you have, you assume that if you have the group of 7 cells, so that is assigned for the available frequency spectrum totally. The same 7 set of frequencies can be reused by another set of the radio channels at a certain distance. It is a concept which is called as frequency reuse. So the total available frequency resources divided into 7 parts, and each part consisted of number of radio channels and allocated to a cell. So the group of cells, what is the meaning of cluster? The group of cells where the available frequency spectrum is totally consumed, it is called as cluster of size. For example, if you have the group of 7 cells means, right? So the group of 7 cells is called as the cluster, right? Cluster of cells or group of cells. So here, what is the meaning for co-channels, right? The two cells having the same number in adjacent cluster. For example, if this is the one cluster and this is another cluster, so if we have numbered here from 1 to 7, here also if we number from 1 to 7, the third cell in this cluster and the third cell in this cluster, it is called as co-channel cells. So two cells having same number in the adjacent cluster use the same set of RF channels, and hence it is called as co-channel cells. Because of the co-channel existence, which uses the same set of frequency at a particular distance, we will be having the limitation in the cellular concept which is called as co-channel interferences. The distance between the cells using the same frequency should be in a range such a way that it should reduce the co-channel interferences. And this is the architecture of the cellular network with the concept or with the notations that is used in telecommunication like MTSC, that is mobile telephone switching network, PSTN, that is public switch telephone network. So here these are all home location register and visitor location register which we are going to which we can study in the communication networks. So here this is the configuration of the cell. So the entire geographic area has been divided into two cells here, and here each and every subscriber within the cell can use the frequency which can be already used by the another user in the another cell. That is the meaning of cellular network. So the purpose of cellular concept is for low power transmission in order to increase the capacity by using the concept of frequency reuse. So it is the architecture which is used to deal with different users density at different places. How can we achieve all these benefits? By partitioning the region into smaller region which are called as cells, and each cell get at least one base station with sufficient number of RF channels, and the user within the cell talks to tower. So how can we divide the cells? How can we divide the geographic area into cells? This is the meaning. So preferably there are many shapes to divide the geographic area into in the form of cells, but hexagonal shape is mostly used. So here How about the cell size? So in some cities it is of in terms of few hundred meters, but in country wise if you take, it is few tens of kilometers. So how why we are going for the division or partition of radio coverage into cells in order to achieve more capacity because of the use of frequency reviews, less transmission power, and it deals with the tolerance and transmission idea locally. And here these are the problems which is now faced by the cellular network in the wireless communication, and this is the formula for co-channel reuse ratio, right? So here how many times the frequency has been reused by the co-channel, that is the meaning here. Q is equal to D by R, where D is the distance between the two co-channel cells and R is the radius of the individual cell, that is the meaning. And here this is the co-channel reuse ratio, and whereas here it is a carrier to interferences ratio, which is represented by the C by I ratio, which is given by this formula D naught divided by the summation of dk. So where N naught and Nk are the path loss components of the desired cell and the interfering base station. And this is the co-channel reuse ratio. So here the difference between the co-channel reuse ratio and co-channel interferences. Here this is a C by I, it is a co-channel interferences, whereas co-channel reuse ratio, it is already we have seen that is Q is equal to D by R, which is equal to given by this ratio. So thank you so much. Next class we will see the concept of frequency reuse. Thank you.